Hello guys and welcome back to my channel. In the previous video we spoke about the SDF files and how convenient they are to give you more flexibility if you want to design your own robotic model and simulate it in the Gazebo environment. But it was a bit tedious to code the SDF file from scratch, so today I'm gonna cover a tool that will allow you to translate your CAD design directly into a URDF and an SDF file. So without any further ado, let's get started. So before I talk about the tool, let me speak a bit about Onshape. So what is Onshape? Onshape is a CAD software that you can use from your browser, and it has version control and all the CAD software tools that you will need to create a robotic model. So it's pretty much convenient because you don't need to install anything actually. So if you head to Onshape, you just need to create an account and then you will sign in and you're good to go. I already have an account, and for today's video we are going to cover a robotic hand model, and it's called actually the Allegro hand, this one. But yeah, like if I open the model really quickly, you can see that here you have version control, and here you can see the different parts with their names displayed and the connections that they call mate. Here you will have the assembly and the different parts that are making up this assembly, and you will have like different tools that you can use to create joints, to insert meshes. So feel free to explore it, and I think it's a really powerful CAD software, so feel free to give it a shot. But today we're gonna focus on the tool itself. So back to the tool. The tool is actually called Onshape-to-robot, and I'm gonna include the link in the description down below so you can navigate it and explore on your own terms. But what I'm gonna do essentially is that I'm gonna use this documentation to cover the important things that you need to know so that you can get to use the Onshape-to-robot tool quickly and conveniently. So first thing we are going to do is the installation. So obviously this tool will use your CAD model from Onshape to translate it into an SDF file, as I mentioned before. So let's open a new terminal. And the first thing we are going to do is to install OpenSCAD and MeshLab, which are needed for the tool. I think I already installed them, but let's make sure. Yes, I already have them. Now the second thing is to install the tool itself. Sorry about that. Okay, so we're gonna use pip to install the Onshape-to-robot tool, and also it has been installed, but I just wanted to show you the commands, and they are included in the documentation as I mentioned before. Now the last step that we are going to do is to head to the following link, and I will also include that in the description. So what we are going to do now is to create API keys that will allow us to use the Onshape-to-robot tool on our PC and give it the access to our Onshape account and the models that we have created inside of it. So I'm assuming at this level you have already created an account to sign in and use Onshape. So if you have done this, you can proceed with the API keys. So here you can see that I have already created some keys, but if you want to create a new key, you just click on this button, and then you have to check the boxes that you think they are most convenient to you. But I think you have like some essential ones, like you should allow the application to read your documents, to write to your documents, and yeah, I think these are the essential ones. But if you face any problem, like check all the boxes. So yeah, that's pretty much it. Once you generate the key, you will get a message that will show you what is your access key and the secret key. So make sure to register these down. And my advice to you is to directly go to the bash RC and once there, you need to include these 3 lines. So first you need to export the Onshape API using this link, and then you will include the Onshape access key, and finally you will include the secret key. So once you do that, you are good to go. Okay. Now, before proceeding with the tool itself, let me speak a bit about the design. So when you get to use Onshape and get to know it well, to design your own robotic models inside of it, there are a couple of things that you should keep in mind while doing the design so that it becomes friendly for the Onshape-to-robot tool. Okay, otherwise you will face problems with this tool. So the first thing is the names of the links. If you remember, we said that a link is a component inside any robotic system. So for example, this part of the finger is a link, this part of the finger is another link, this palm in here is a link, and these links are connected by joints. So for the links, you can name them. So let me actually open a file where I already named them. All right, so here is the model where I named the links. So for example, here you should keep in mind that when naming a certain link, you should start by link underscore, just like here, and then you follow up with the desired name of your link. In this case, I called it palm link. So for this particular example, when the tool will do its work and it's gonna transform your CAD design into an SDF file or a URDF file, the link will appear inside these files under the name palm link. Okay? And I did the same thing, obviously, with other links. And make sure to follow this procedure for all the links inside your model. Okay? Now, I know this is a bit tedious, but if you do it every single time you include a new link, it will like, I think it won't be a lot of work. It won't feel like a lot of work. And also the convenient thing is that when you want to change a thing about your robotic model, add something, modify something, it will be much easier to use the tool so that you can convert the modifications, the robot with the modifications, directly into an SDF file, rather than starting things from scratch and follow the code and modify it. So yeah, the second thing is the joints. For the joints, the name should start by DOF underscore and then followed by the name of the joint that is desired. So in here you have joint 12.0, you will have joint 7.0, you get the point. Now, once you do this, these are the most important requirements. You're good to go now. The second thing that I would like to cover is the creation of a .json file. So, to keep things organized and to avoid any problems, you need to create a directory where you will keep everything. You will keep the mesh files that will be generated later on, as you will see, the URDF and SDF file for the robot, and the JSON file as well. So I called it my robot, and inside of it, the first file you will create is called config.json. Okay? What does this file do? I already included some of the things. This will include information about your CAD design in Onshape that you created in Onshape, so that the tool will use this information to fetch this model and translate it into an SDF or a URDF file. So the information that you will include are far more than what's included in here, but these things are the essential ones, all right? So feel free again to browse the documentation for more details and information. Now, if I go back to my browser, I'm gonna show you step by step how I was able to find the value for each of these arguments or parameters. So, if we go to our model and the version that we are trying to convert into an SDF or URDF file, if you go to the URL in the search bar, you will see a list of numbers and letters after the word documents. This is your document ID, all right? And you should include that under the parameter document ID in here, okay? Now, the second piece of information that you need is the version ID after the letter V, very self-descriptive. And then you need to specify the assembly name. It will appear in here, and also it will appear in here, okay? And once you do that, you can specify the robot name. In this case, I called it robotic hand, and this name will be used in the generated URDF and SDF files. And also, it's essential for you to create a package name. And you will see later on that this is very convenient to allow Gazebo to fetch the meshes that are needed to visualize the robotic model and place the robotic model inside the simulation environment. And finally, you need to specify the output format. Now in this tool, they gave you two options, the URDF and the SDF. I'm not gonna use the SDF because normally it gave me problems and I had to tweak the SDF manually to solve that. Instead, I'm gonna follow another approach. I'm gonna generate a URDF model from the CAD design using the tool, and then I will use another tool provided by Gazebo to translate the URDF into an SDF file. This works for me with no problems, and I recommend that you do the same. So once our JSON file is ready, the next step would be to use the command that will translate our CAD design into a URDF file in this case. So let me open the terminal. So in here, as you can see, we have on the desktop, we have my robot. So make sure that you are in the parent directory of this folder called my robot, not inside of it. And then you need to run the following command: Onshape-to-robot. And then my robot. So I specified, again, my robot is the directory that includes the JSON file. So you just need to specify this after the command. And as you can see, if you browse it quickly, you can see that the tool has identified the assembly, and which is good. And then it has identified the joints. In this case, it gave me a warning that I didn't place limits, but you can use Onshape to place limits. And this is like completely easy and doable. I did not do it. Feel free to do so. You can see the total degrees of freedom. It's 16 degrees of freedom robotic hand. Here you have like every single part generated, along with the inertia and other related information, and you have the URDF file. Now, if I head to the my robot directory, you can see that we have in here the mesh files were generated with the .stl extension, which is just an extension for mesh files. And here you will have the robot.urdf. Okay, so we're good. Now the last thing that we are going to implement is the translation of the URDF file into SDF, as I mentioned earlier. So let's change directory, and then this is the file that I'm interested in. So what I'm going to do is use a GZ SDF. Again, this is a tool provided by Gazebo Classic. Robot.urdf. And then we need to translate it into robot.sdf. All right, and as simple as that. So here you go. Now we have the robot.sdf. Now, if you followed my previous video, you will notice that I explained how to properly create a model inside the hidden Gazebo directory so that you can access it quickly, and it's the professional way to do it. Okay, so cd Gazebo list cd models, and let's open VS Code in here. So I'm gonna create a new folder. I'm gonna call it robotic hand. Inside the robotic hand, if you remember, we needed to create the meshes directory, and then we needed to create two files. First, not really. So this one should be called model.config. I'm gonna quickly copy and paste from another model because it's gonna be similar. We're gonna tweak it a bit. So here you can call it Allegro hand. I'm gonna call it robotic hand. The model is model.sdf that we are going to include later. This is the version, the author name, the email, a model for the Allegro hand. This is a quick description. And what we are going to do next is to grab the mesh files that we have generated using the tool, all of them with no exception, and then we're gonna actually drag and drop them under meshes. So this is the right place to put them in. And finally, I'm gonna drag and drop the robot.sdf, and this is going to be placed in here. And do not forget to rename it to model.sdf to stick to the convention. Okay, so let's have a quick look over the SDF file. So you have the SDF version, you have the model hand, the model name as I specified it to be, robotic hand. This was specified in the JSON file if you remember. You have the links. For example, you can see the Palm link, and this was specified in the Onshape model if you remember. And here you will have the collision, the visual parts, everything was automatically generated for you. The inertia, the mass, this will also depend on the material that you specified in Onshape. So this will be calculated using the material and the volume of the part, and you get the point. Now, if we want to test this model, like does it appear clearly and correctly in the simulation environment, I already created a Word file. I placed it on my desktop. And if you remember, this was important if you want to launch a simulation and include a model inside the environment. So in here we already have the sun and the plane, the ground plane. I already explained about this in the previous video. Feel free to review it if you want to. Now we are going to include the URI. So in this case we have model, and if you remember we called it robotic hand. This was the name of the directory, and also this was the name of the model inside the SDF file in here. Yeah, robotic hand. Make sure to save everything, and then once you're done, you can open the terminal and go again to desktop, home desktop, and then you can use Gazebo and my word.word. So this will run the simulation with the robotic hand inside, hopefully. And here you go. You already have the hand that you saw previously in the Onshape software. As you can see right now, it's in the simulation environment. It has already fallen because it wasn't designed to be simulated on its own. This is a hand that's supposed to be mounted in here on a robotic arm. So that's completely normal. So yeah, that's pretty much it, guys, for today. I hope you enjoyed the video, and I think this tool can be really convenient for you when you handle like big projects that include complicated robotic designs. It's more convenient to do the design in a CAD software and then translate it into a code. And right now, if you already watched the previous video about SDF, you can understand what's going on, what's the SDF file, and you can tweak it a bit instead of creating it from scratch. This will conclude actually the Gazebo series, and I'm gonna create a new series up next that will hopefully make your life easier. So stay tuned and have a good one.